For as long as we've had telescopes, we've been trying to make sense of the heavens. And when we started mapping where the galaxies are, we found something odd. They aren't just scattered around like dust in a sunbeam. Instead, galaxies clump together into huge clusters and long, stringy filaments, all separated by giant, empty voids. The universe, it turns out, has a structure. But why? You see, the stuff we can actually see, the brilliant stars, the gas, and the dust, simply doesn't have enough gravity to explain this. When we look at how galaxies spin, the stars on the outer edges are moving so fast they should have flung themselves off into the void billions of years ago. Something else is there. Something massive, unseen, and absolutely essential, providing the extra gravitational grip. Scientists call it dark matter. According to our best theories, it accounts for a staggering 85% of all matter in the universe, yet it's completely invisible. It doesn't emit, absorb, or reflect any light. For decades, this was mostly just a placeholder in our equations. We knew it had to be there, the glue holding everything together, but we couldn't see the glue itself. Until now. The James Webb Space Telescope has just given us the most detailed, high-resolution map of dark matter ever produced. For the first time, we are not just inferring its existence, we are seeing the very structure of it. Webb has pulled back the curtain on the invisible scaffolding of the cosmos, and what it shows is more incredible than we ever imagined. To understand the magnitude of this, we have to go back. The puzzle of this missing mass really took hold with Vera Rubin's work in the 1970s, which showed individual galaxies were rotating at impossible speeds. The only explanation was that each galaxy was sitting inside a massive, invisible halo of this dark matter. Without it, our own Milky Way would tear itself apart. But what is it? That question has driven decades of research. We know it's not just dim stars or cold gas. We know it's not a mistake in our understanding of gravity. Einstein's theories have been tested again and again. It must be some new kind of particle, something totally outside the standard model of physics we all learn about. For all our progress, we were still in the dark. We had the blueprints from our computer simulations, which predicted a vast, interconnected network often called the cosmic web. But we couldn't see the building. Early attempts to see it, like the one by the Hubble Space Telescope back in 2007, gave us our first blurry clues. But we were waiting for the cosmic window to be wiped clean. So, how do you map something that's literally impossible to see? The answer lies in one of the most elegant ideas in physics: gravitational lensing. Einstein told us that massive objects warp the very fabric of space-time. Think of it like putting a bowling ball on a trampoline. If you roll a marble past it, the path of the marble will curve. Light does the exact same thing. As light from a distant galaxy travels across the universe, if it passes a huge clump of matter, like a galaxy cluster or a massive filament of dark matter, its path gets bent. Sometimes this creates beautiful, dramatic arcs in an effect called strong lensing. But most dark matter is more spread out, so scientists use a much more subtle effect, weak gravitational lensing. This causes tiny, almost imperceptible distortions in the shapes of distant galaxies. A galaxy might look slightly stretched in one direction. One galaxy isn't enough, but by analyzing hundreds of thousands of them, scientists can spot a collective alignment, a dead giveaway that a huge, unseen river of dark matter is sitting between those galaxies and us. And that is precisely what an international team of scientists did. Published Monday, January 26, 2026, in Nature Astronomy, the team used Webb to stare at a patch of sky in the constellation Sextans known as the Cosmos Field. For 255 hours, Webb's piercing infrared vision identified nearly 800,000 galaxies. By measuring the tiny distortions in their shapes, they subtracted the mass of everything we can see. What was left was a map of the invisible. Take a close look at this image. The resulting map is overlaid in blue on top of the deep field of galaxies. The brighter the blue, the more dark matter there is. And what emerges is a breathtakingly intricate network. We see the dense knots of the web, the massive galaxy clusters where thousands of galaxies are anchored by a huge concentration of dark matter. But more importantly, we can now clearly see the strands and filaments connecting them. These are the vast bridges of dark matter, stretching for millions of light years, acting as the skeletal system of the universe. As lead author Diana Scognamiglio of NASA's Jet Propulsion Laboratory said, "Previously, we were looking at a blurry picture of dark matter. Now we're seeing the invisible scaffolding of the universe in stunning detail, thanks to Webb's incredible resolution." And that isn't an exaggeration. Webb's new map is more than twice as sharp as the previous best from Hubble. It contains data from twice as many galaxies as Hubble's map, and 10 times as many as could be mapped from the ground. This leap is thanks to Webb's sensitivity and its MIRI instrument, which can see fainter, more distant galaxies. More galaxies mean more data points, which means a sharper map. Where Hubble saw blurry clumps, Webb resolves fine, thread-like filaments, revealing the cosmic web as it was when the universe was just half its current age. So, why does all this matter? First, it's a stunning confirmation of our model of the universe. The map shows that the galaxies and gas perfectly trace the underlying structure of dark matter. As co-author Richard Massey of Durham University stated, "Wherever we see a big cluster of thousands of galaxies, we also see an equally massive amount of dark matter in the same place." This map shows us that dark matter and regular matter have always been in the same place. They grew up together. This lays the universe's history bare. After the Big Bang, tiny fluctuations in dark matter density began to grow, pulling in normal matter. Dark matter built the gravitational framework first, and normal matter fell into these gravity wells to form the first stars and galaxies. This map shows us that process happening. It shows that dark matter is the true architect of the universe. Without this invisible scaffolding, the elements necessary for life may never have been gathered into galaxies. While dark matter isn't something we encounter in our daily lives, it has profoundly influenced our very existence. This discovery moves us from just detecting dark matter to truly surveying it. This map is now a benchmark for astronomers worldwide, and this is just the beginning. While incredibly deep, this is just a tiny fraction of the sky. Upcoming observatories like the Nancy Grace Roman Space Telescope will apply these same techniques to areas thousands of times larger. We are on the cusp of moving from a local map to a global view of the entire cosmic web. We've spent our entire existence living inside a grand, invisible structure without ever knowing it was there. We saw the lights of the cities, the galaxies, but were completely blind to the hidden framework of roads and foundations connecting them all. Now, that veil is being lifted. The map created by the James Webb Space Telescope is more than a scientific breakthrough. It's a cosmic revelation. It shows us the universe isn't a chaotic accident, but an intricate, ordered, and deeply connected place. The skeleton has been revealed. Now the real work begins to figure out what it's made of. If you want to stay updated on the incredible discoveries from the James Webb and Roman telescopes, make sure to subscribe and turn on notifications. The universe is just starting to give up its biggest secrets, and you won't want to miss what comes next. Thanks for watching.